Hi. Okay, well, I used the Advanced Amiga Analyzer, which is comprised of the following things. There is a software disk, which is currently in the computer, a serial port tester, with 2 LEDs, a parallel port tester, once again with 2 LEDs, a video port tester with 3 LEDs, and a mouse port tester with 1. Those LEDs basically pertain to the pins that provide power for the particular ports. So the mouse uses 1, the serial ports and parallel ports, or the serial port and parallel port both use 2 pins.
Sean, line 1, please. Sean, line 1.
Be back in a minute. Sorry about that. Just a woman calling to inform me that one of the people in charge of one of the community services we're advertising on the community channel had changed. The person to contact no longer works there. It's someone else now, so I'm changing the name. Anyway, I'm sure you really care. I used the Advanced Amiga Analyzer to test the computer, because as you saw, even after replacing the CIA chips, it didn't work properly. Following that, I replaced the 68,000 CPU and the Gary chip, basically replacing all the old chips with the replacements that I received in the mail. Still no change at all. Yeah, so I used the analyzer to try to determine what the problem was. And basically what happens is, provided every single LED on these little testers is lit, there's no problems with the particular port. Not so with the video port. The yellow and red ones were lit, but the green one, the 5-volt one, was not. So I asked it what the problem was, and it pinpointed it down to a capacitor and I don't know, a resistor or something like that. Yeah, basically two little electronic components on the motherboard near the video port which supply power to that particular pin. There's something wrong with them. It's not getting power, and consequently the display is screwing up constantly. So I was wrong. It wasn't the CIA chips after all. I thought it was. One of the symptoms actually for a faulty CIA chip is the drive light not lighting. I assume they mean the hard drive. Maybe the floppy drive, I don't know. Anyway, the hard drive light wasn't lighting, and I realized that was because I had rewired something wrong one time when I took it apart in an attempt to fix it a while ago. I rewired something wrong so that the wire going to the hard drive light was plugged into the wrong connector, so I just fixed that and everything. So everything is as perfect as it can be right now. But basically what this boils down to is I can't fix the problem myself, so we're going to have to get a professional to fix it. Which is a shame, because I was hoping it would be something simple like just a chip needing replacement or whatever, because that would have made it so much easier and so much less time consuming. So it looks like I'm going to be Amiga-less for a while. Yes, I'm going to be without Amiga. I hate it when this stuff happens. But we won't be taking it to Micromart. Yes. Yeah, a while ago actually, when these problems began, Mindy phoned around the city, called like literally every single computer repair place in the city, looking for a place that repairs Amigas. Of the roughly 150 she called, 3 of them repair Amigas. 4 if you include Micromart. Only problem is I can't remember what those places are, so I've been trying to get in touch with Mindy to see if she could get me those numbers. As a matter of fact, I'm going to try again right now. A second, we'll do it like this. I'll just let that ring while I'm talking to you for a bit. Yeah, so I typed up a nice little letter to give to the repair person, whoever it may be, just explaining the problem and explaining that we'd appreciate it if you could fix it as quickly as possible. Also included the information I acquired from the analyzer to make it a little easier for the person, so we won't have to wait. Like, most of the waiting time is pinpointing the problem, you know, I imagine, so hopefully we won't have to worry about that anymore. And it doesn't sound like Mindy's home. I tried twice today. It's possible she's at her grandmother's. She was supposed to go to her grandmother's yesterday, but didn't. She went to the library instead, and she's probably there now, like, making it up to her. Which is a shame, because I don't have her grandmother's phone number on hand. So that's basically what's happening. Pretty depressing, really. So, in case you're wondering why you haven't seen any nice toasterized titles lately, well, that's why. Because of the way in which the computer is screwing up, it will not run the video toaster at all. I don't think it's a problem with the toaster itself, it's just because of this video port thing. It's one little pin screwing up the whole system. Quite irritating, I must say. Oh, I remember what else I wanted to do. I was checking out the Amiga 2000 manual, the user's manual. I've got the monitor below the camera again. I'm just checking it every once in a while to make sure I'm still in focus. And in one of the appendices in the back, I found out they have descriptions of some of the custom chips. So I thought I'd sort of do a little addendum to my guided tour earlier and read it to you if you haven't read it already. You know, I just thought you might be interested. First off, there is the Fat Agnes chip. The Fat Agnes chip has the following features. Bit Blitter, which uses hardware to move display data, allows high-speed animation, and frees the CPU for other concurrent tasks. See, that's one thing the Amiga does that other computers don't. It takes a lot of the load off the CPU through the custom chips, right? Unlike, say, IBM's, where they do everything pretty well through the CPU. Display Synchronized Coprocessor controls 25 DMA channels, allows the disk and sound to operate with minimal CPU intervention. Once again, taking the load off the CPU. Generates all system clocks from the 28 MHz oscillator. Generates all control signals for the video RAM and expansion RAM card, and provides the address to the video and expansion RAM multiplexing. Also provides you, well, the built-in one provides you with 0.5 MB of chip RAM. The one we've got provides us with 1 MB of chip RAM. Chip RAM is basically everything I've just described to you. More megabytes, the smoother it runs, the faster it runs. The Super Agnes, of course, has 2 MB of chip RAM, and we'll be getting that soon. And now, the 8362. More commonly known as the Denise chip. Features of the Denise chip are many different resolutions. This is just the regular Denise chip that comes built in. Many different resolutions, 320 by 200 up to 640 by 400. 4096 colors simultaneously on a TV or RGB monitor. That's the highest number of display colors available. Below that you can have 2, 4, 8, 16, 32, or 64 extra half-bright colors. You might want to consult your paint program manual for information about 64 color extra half-bright. Or maybe you don't have a paint program yet. 64 color extra half-bright, basically you've got a palette of 32 colors, then you've got an additional palette of the same 32 colors, except they're only half as bright as the first set of 32. You know what I mean? And that allows you to do some nice little shadow effects and so forth. Okay, to continue, 8 reusable sprite controllers, 60 or 80 column text, and same software for all TVs and monitors. Another one of the expansion chips we'll be getting, or the upgrade chips we'll be getting, should be coming any day now, is the Super Denise, which has more resolution modes and all sorts of great stuff. Okay, I was slightly mistaken about the Apollo chip. I thought it was for graphics. It is in fact for sound. Now, this is something I've been wondering for a while, actually, which chip controlled the sound. Here's a look at it. There's the Apollo chip. I figure since you're into all this technical stuff, you'd find this interesting. Features of the Apollo chip are as follows. 4 voices of sound, output configured as 2 stereo channels, 9 octaves, complex waveforms, uses both amplitude and frequency modulation, input-output controls for disk data and controller ports, micro-disk controller, and interrupt control system. Most of that means absolutely nothing to me, but I'm sure you'll be able to make some sense out of it. Now, they don't seem to have the Gary chip in here. But I read somewhere today, I can't remember where. Anyway, the Gary chip basically controls your disk drives, and that's about it. floppy disks specifically, or it's something to do with floppy disk control. I think that about wraps it up for the custom chips. The CIA chips control zillions of things. They control your drive lights, they control most of the pins for the various ports. Specifically, I think the serial port and the parallel port are all controlled by the CIA chips. And parts of the display, like certain aspects of the on-screen display, are controlled by the CIA chips as well. Oh, one thing the Super Denise chip was going to do, gives you flicker-free display. You may have noticed interlace flicker from time to time. Oh, some information about the video toaster, specifically toaster paint. A full-blown 24-bit image, as far as I'm aware, which can display all 16 million colors at once, apparently, like 16.7 million color palette. You can display them all at once if need be, except not on the computer screen. It outputs it as an NTSC video signal so that it can be put directly onto VCR. That's why you won't be able to see a 24-bit picture on an RGB monitor, but you will be able to see it on a TV. You might be able to see it on a multi-sync monitor though, I'm not sure. Toaster paint, how it makes up for that, when you want to of course use it on the monitor, is it displays the picture in ham mode. Or the close-up version anyway is in ham mode, and then when you render it, it transfers it into 24-bit. Don't ask me how, I have no idea, but that's what I've determined. How I figured that out was because ham has a tendency to have color fringing down the side of the picture, sort of like little jaggedy, or I can't really describe it, sort of like, it looks like the picture's broken up a bit on one side or whatever, you know, or just sort of scribbly on one side. I mean, it's a temporary problem that won't come out in your finished image. That's just a problem with the display. Like when you move it around, like when you look at a picture in toaster paint, scroll around the screen a lot, because it's only a quarter screen you're looking at, as I'm sure you know. Scroll around, you may notice some fringing on the side, as it's called. If you see it, you'll know what I mean. It's usually greenish in color. If you see it, you'll know what I mean. Yeah, I thought it would be a good idea to send you this on an 8mm tape so you could see all the fine details better. Yeah, I wanted you to be able to see all the fine details of the chips and the diagrams and so forth as best as I could show them to you, so I figured I'd put this one on, this concluding part to video letter 11, put it on an 8mm tape for you. Yeah. Oh, we also got another mouse. I'll show it to you. This is our old mouse. It's very worn out, and you may notice the ball is quite dirty. See that? Yeah. So, I ordered a replacement mouse from the same place I got the analyzer from, a place called the Grapevine Group. They supply a lot of software, hardware, etc. for the Amiga. Anyway, this is our new mouse. Much more sleeker and high-tech looking, I think. With a nice clean ball underneath. This can be used for the Amiga or the Atari computers via this switch. Now it's an Atari mouse, now it's an Amiga mouse. See the indicator at the top here. Yeah, so we got that, we got the analyzer. We still haven't got all the replacement chips that I ordered. We only got the 68,000 CPU, the Gary chip, and the 2 CIA chips. There's a set of custom chips I ordered called the Emergency Startup Kit, which has basically all the major chips, the Denise chip, Paula chip. I ordered one with the Super Denise chip because I want to have it upgraded to that. So that's it for now. If I had the RF adapter, I'd show you some Amiga stuff, like what I could get to work anyway. But unfortunately I don't, so I can't. Oh well. Anyway, so I'll talk to you in a bit. It's still November 24th, Wednesday, November 24th, 1992. Over the time is 2:19 p.m. So I'll talk to you later. Bye.